Hi, I'm James Davis with SoftTech Engineering, and today we're going to show you how to hook onto a SIS valve, a block valve, anything with a solenoid. In this case, we are doing a SIS valve. With the SIS valve, we have a double-seated ball valve, we have a rack and pinion actuator, and we have our limit switches, along with our solenoid. Now this solenoid could be AC or DC solenoid in this case. In this case, it's an AC. So one thing that we want to talk about first is how do we test and get into reading the pressures. We want to read the pressures of our actuator because that's how we get our information about our springs, the spring force. We also read the torque of our actuator. So we need to read the pressures. We'll also read the pressures of our supply through our regulator. So in describing this, we're going to talk about how do we get into a Namur block. In our kit, we have a kit that we have created for getting in with the Namur solenoids, okay? This kit this block will actually slide in behind. We'll take the screws out, we'll slide this in behind, and in the kit there are some longer screws with wing nuts. As we take that out, we slide that through, and then we screw our long bolts in, and then we use the wing nuts to tighten this up against the O-ring around the solenoid and the O-ring around the actuator. So this is our block or block valve SIS package. There's also a spring in here we're going to describe, and we're going to use that today on how we get onto the shaft. Now in this case, we have the ability to use our adapter, our half clamp, and get in here and read our shaft. But I want to show you in this case how to get onto a shaft that is greater than 2 inches. This one's actually smaller, but I want to give you an example of how to get onto a shaft that is greater than 2 inches in diameter. And the way we do that is it's called wire wrapping. So I'm going to describe to you how that's done. With our string pot attached to our fixture, we have our adapter, our U-shaped adapter, and we have a wire that we've already attached to that. And this is basically how we're going to hook onto. So we're going to come on and we're going to come into the side of the yoke and we're going to tighten that up. Now we have something very rigid and stiff to be able to hook onto. Now we're going to take our wire and we're going to wrap around the shaft at least twice, okay, at least twice. So we'll come in around the shaft. There's once, and here is twice. Now, once we've come around it twice, we have a spring. It's a 5-ounce spring. Our solenoid, or our string pot, has a 5-ounce pole on its spring. We are going to hook this into our spring, and we are going to attach our spring into the nut right here for adjusting right there. So we have the ability now, as the valve moves, we have a spring force here and a spring force here, and then the friction around the shaft maintains how tight around there, and we get a rotation. So we can use our string pot now to set our open on our ball valve. So we set our open and set the nut, make sure that the adjustment is set right. Then we will close it, but we'll close it so that we'll use the string pot to rotate 90 degrees. That way we can now set our closed side. So we set our open side first on the ball valve so we get a straight shot through. Then we'll rotate at 90. That way we'll get our 3-degree rotation inside the ball so that we're centered in the ceiling on either side of the ball. So that gives us our 90-degree rotation. So this is how we wire wrap and get on shafts that are bigger than 2 inches, okay? Once that's hooked up. Next, what we're going to hook up is we are going to attach to our solenoid. This is an AC solenoid. We have an AC solenoid power box. We have a 120 volt AC available. We have 48 volts, 24 volts, and 12. So if we're using the AC, we'll plug into this port, or if we're using the DC, we'll plug into this port with this cable. Now we have a battery power supply. We can turn that on, and as we turn this on here, the switch, we can turn on and we can see that we have power or power on any one of these. These are radio buttons, so you can only turn one power on at a time. This is great for being portable. If you're out in the field doing testing, maybe there's a shutdown, a turnaround, the power is off. How do we test solenoids? Well, we want to test the solenoid because we want to test the coil. The coil is very important. How quick does the coil respond, and how much coil current are we going to be drawing? And so in our software, we'll be able to read the coil current and make sure that our solenoid is correct and it's reading right and it's responding quickly. If we're doing SIS testing, we've got to get rid of all the delays in either the open side or the closed side for our timing. So this is a great little tool that we can hook on. We can hook it anywhere, hang it. The battery can also, has a clip on it, we can hang it also. You have also lights with this, so you have battery power, and you can charge any USB port. Okay, so it's a great independent tool. We're going to use this in this demonstration where we will be testing our valve. We're not going to demonstrate the software at this time. We're going to demonstrate the attachment. So if we want to now attach to our box, we will show that here in just a second. We are going to attach to our solenoid. Now, we'll plug into the AC, and on this side of it, we will bring our power across. Now, our box will also do two solenoids also, common. This one has no power on it, and this will have power on it at the time. So if we have double solenoids, we have the ability to do double solenoids or single or four-way solenoids, okay? So we're gonna hook up standardly our two long ones. Our short one has the power on it. So we'll hook up our AC power, and we'll leave this one off since it's a single solenoid, okay? Next, we are going to attach to our interface box, okay? Our interface box is how we're going to control all of our signals, commands, and feedback reading. So we have a 4 to 20 signal. In this case, we will not be using the 4 to 20 signal. We will be reading our position, which is our string pot. We'll be reading our single acting spring return actuator, and we don't use the yellow signal. That's for I to Ps. If we have a double acting, so here we have two ports, we have double acting, we can read the double ports. And we'll also be reading supply. The extra ports down here are going to be for doing seat leak testing, which we'll show in another video, and also setting up our limit switches. So this is how we set up our limit switches, is through this. So when we look at our limit switches, we want to make sure our limit switches are set exactly on the open side and on the closed side. We don't want them set anywhere in the middle, because that's a dangerous situation where if the valve sticks, the limit switch activates, says it's open, and then the valve sticks after that, you have a problem. So we want to make sure our limit switches get set exactly on the open side and exactly on the closed side. That way the control room knows it's open or closed exactly. And with our testing, we can verify where the limit switches are set. So this box is going to attach to all that. We also have a solenoid relay. That's the relay that will do our on-off switching. We can do up to 2 amps with this relay. Most solenoids are going to be 0.5 amp or less, so we have plenty of power on that AC or DC solenoid relay. It's also where we'll be reading our current draw of our AC or our DC solenoid. So this will attach to our solenoid box, and we'll show you how that attaches. First thing we want to do is we want to attach to our box. So we will plug into our computer using our USB cables. We will then plug into our box, our interface box, our data acquisition card is now communicating with the flashing light. We will plug in the top. We will connect. We would have no power on the top at this point on our top card until we start the software. So the light will remain off. Now we will attach all of our signals to our interface box. The first one we're going to attach to is, we have our solenoid box. We're going to unplug this one that one's plugged in so that we can manually activate the solenoid. We have a cable that we're going to connect between our interface box, which goes into our DC relay, to our solenoid box. This box here will now control this box and turn on and off highly accurate. But basically within milliseconds, it'll activate the solid state relay. So we have high precision accuracy on our on-off control. So when we do our time testing, again, we're doing 1,000 samples per second. So as fast as this valve can move, we can read. And also we have a 16-bit data acquisition card. So highly accurate and high resolution gathering of data, okay? So that now connects our two boxes together. Next, we will hook up our interface, or our cabling to our interface box. So in this case, we are not sending a 4 to 20 signal. We are going to be sending an AC signal or a DC, depending on the solenoid. So we don't have to hook up the solenoid or the 4 to 20 signal. We will attach our string pot, so for our position, and we will also attach our actuator pressure and also our supply pressure. Now, for good measure, we always like to hook everything up, but in this case, this is the testing that will be done. If I had a double acting actuator that was rack and pinion, I would plug in that one. I'm just going to plug in this one so it's out of the way, doesn't get pinched, and since we're still not using this, we'll still plug it in to make sure that it's protected. So we have our box attached. We will now grab our cables that we're going to be using. We have our position, so we'll hook up our position. We have our actuator pressures and supply pressures, so we'll grab that. Now, one thing that we have is we have our pressure sensors. Now, one thing our block has is quick connects, and in our block package, we sell these quick connects for you so that it's easy to get in and out of this block. So this block is attached here, and we basically will hook up our pressure here. We will also bring in our supply and read our supply pressure here. So we have our supply, which is the gray. These are all 0.1% accurate, and they are temperature compensated. So we have our single acting spring return actuator hooked up with our supply pressure also hooked up. Okay? Next, we are not going to be reading any of these other sensors unless we have a double acting actuator. Our final attachment is we want to read our limit switches. So we have a limit switch cable that can come with the block valve package kit. This is an optional kit that comes with the profiler system. So if you want to do on-off, this is our block valve package kit. So we are going to plug these in to separate ports here. We're always going to use our number 2. So one, we're going to plug into the position here so we can read the position of the limit switches. We'll plug into the second red one, and we'll also plug into the second green one. That will be limit switch 1 is the red one, limit switch 2 is the green one. Now on the opposite end here, we have some clips. Again, limit switch 1, we will now put this into the normally closed of limit switch 1 and the normally closed of limit switch 2. This is how we're going to set our limit switches. So both of them are set on the normally closed side. So I have brought out the wires. We're just going to clip directly onto limit switch 1. And we're going to also come into limit switch 2. Those were previously wired into here so we can see that. So we now have our limit switches all set up and hooked up and ready to go. So the testing that we're going to be gathering is there'll be a graph of our limit switches, activating limit switch 1 and 2 on the open side and limit switch 1 and 2 on the closed side. Our solenoid, we will be reading our solenoid current draw and also the timing of how quick does our solenoid activate and reactivate, okay, on, off. We'll read our supply pressure, and we will also read our actuator pressure. Our actuator pressure will also give us our torque readings. It will also give us our spring forces, and basically everything we need to know about anything with the actuator or leakage of the actuator. If we have double acting, we'll have a separate one on this side, so we have both actions there. So in this case, we are all hooked up and we are ready to do testing. We'll turn on, we got the power turned on. We're not going to go through the software right now, but the final thing that we'll do is we'll turn on we'll come to our profiler software package and we will start our profiler. Once the software starts, we now have power to all of our sensors and through the box, and we have a blinking light and then we have a solid green light. So once the software starts, we have power to all of our sensors and we are ready to enter the data. And one final thing in the software is we will select what we call SIS or solenoid block valve testing. Once we go into the software, this will be a separate demonstration, but initially that's how we're going to go into it to be able to read and do all of our SIS block valve testing. So for more information, please go to our website or contact me through that website, James Davis. We can do demonstrations, we can send you information, we can do through Teams or come to your facility to do a live demonstration. So thank you for your time.